This last video goes over the end of the Exam 2 review sheet. The first two questions are going to be about solving radical equations. Now, first we have to know, how do we recognize that we need to be taking the steps to solve a radical equation? Well, remember, radical means you're going to have some sort of root in the equation. And then remember, equation means we're going to have an equal sign. So if you look back at the last 6 or 7 questions we did before this, they didn't have an equal sign, so we didn't have to solve. Okay, now we're going to be looking at questions that have an equal sign. We're going to have to get actual answers. So the first step will be to isolate the radical, which means the radical needs to be alone on one side of the equation. The second step will be to square both sides of the equation, because that's going to cancel out the radical. If you have a square root and then you square it, they're opposite operations, so they cancel each other out. The third step is going to be to solve the remaining equation. Now, it might be a linear equation that we solve, which would be easy, or it could be a quadratic equation that we have to solve. And then the last step will be to check for extraneous solutions, which means make sure your solutions work. Every so often you will get a solution that doesn't actually fit into what the problem asks for. Okay, so question 30 gives us the square root of 3x plus 7 minus 4 equals 0. So you can already see that the radical is not isolated on the left side of the equation. We need to move that minus 4 to the right side. When we move a negative 4 to the other side of the equation, it becomes a positive 4. So this is going to be equal to 4, and on the left side we'll have our radical isolated, 3x plus 7. Okay, now remember, to get rid of the radical, step 2 says we need to square both sides of our equation. Those are going to cancel out, and we'll be left with 3x plus 7 equal to 4 squared, which is 16. And now we're going to solve this simple equation. We're going to subtract 7 on both sides of the equation. And then we're going to divide by 3 on both sides. And that leaves us with x equals 3. Okay, now we can plug that back into the original problem and check. We have 3 times 3, which is 9, plus 7, which gives us 16. Now when we do the square root of 16, that gives us 4. And 4 minus 4 equals 0. So that solution checks out. That's good. All right, number 31. We can see that the radical is already isolated on the left side of the equation, so we can start by squaring both sides of the equation. And on the right side, we actually have to square this entire quantity, so I'm going to put it in parentheses. So we're going to be left with x plus 2 equals x plus 2 times another x plus 2. All right, so on the right side of the equation, we're going to need to distribute that out. So I have x times x, which is x squared, x times 2, which is 2x, 2 times x, which is another 2x, and 2 times 2, which is 4. Now on the right side, we still need to combine like terms. We can combine the 2x plus the 2x. So we have x plus 2 equals x squared. We're going to combine and get 4x and plus 4. So now we look at this equation and we can see that it's a quadratic equation because we have x squared. So we know we need to get this equation equal to 0. So in order to get that equal to 0, we need to move this x to the other side. And we need to move the 2 to the other side as well. And that's going to give us now 0 on the left side of the equation. And on the right side, I'm going to have x squared plus 3x plus 2. Now I need to factor that trinomial. Remember, when you factor a trinomial, you look at the last term and you're looking for the factors of the last term. So we have 1 and 2 as factors of 2, and they add to 3 if they're both positive. So we can write 0 equals x plus 1 and x plus 2. Now remember, the next step is to set each of those factors equal to 0. X plus 1 equals 0. X plus 2 equals 0. And now we're going to solve each of those equations. Subtract 1 on each side. And we get a solution of x equals negative 1. And I've done this review sheet already and plugged that into the original problem and checked it, and it worked. You can go ahead and do that on your own time. Same with this second solution. We subtract 2 on both sides, and we're left with x equals negative 2. 2 solutions to this problem. All right, the next part of the review sheet goes over imaginary numbers. Now, things we need to know about an imaginary number. First thing, the square root of negative 1 equals I. So anytime you take the square root of a negative number, you need to have an I on your answer. For instance, if you had the square root of negative 25, that would be 5I because you're taking the square root of a negative number. You also need to know that I squared is equal to negative 1. So anytime you get an I squared in your work, you can replace that with a negative 1. All right, so the first question says the square root of negative 36. Well, we know that the square root of 36 is 6, and since it's negative, we have to put I for it's an imaginary number, 6I. Number 33, we're going to be subtracting these two binomials. So the first thing that we need to do is distribute our negative sign. So we have negative 3 minus 2I. A negative times a negative makes that a positive 7, and then a minus I. Now we're going to combine like terms. We can combine negative 3 plus 7, that's 4. And we can combine negative 2I minus I, that's negative 3I. So on that one, we're just subtracting. The trick is not to forget to distribute that negative to both terms in the second set of parentheses. All right, on number 34, we're going to be multiplying the binomials together, so we're going to need to distribute. We're going to distribute the 3 first to both terms. 3 times negative 4 is negative 12. 3 times negative I is negative 3I. Then we're going to multiply the 2I to both terms. 2I times negative 4I is negative 8I. And 2I times negative I is negative 2I squared. Now we have some work to do. First thing we can do is we can combine the negative 3I minus 8I. So now we have negative 12 minus 11I. Now we also remember that I squared is negative 1. So we can replace that I squared with a negative 1. Now we're going to rewrite this. Negative 12 minus 11I. And then negative 2 times negative 1 is plus 2. Now we can combine the negative 12 and the positive 2. That's a negative 10. And we bring down our minus 11I. All right, number 35. Just like radicals, you cannot have imaginary numbers in the denominator. And remember, to get rid of the radical in the denominator, we multiplied by the conjugate. We're going to do the exact same thing with these imaginary numbers. So we need to multiply by the conjugate of 2 plus 5I, which we know the conjugate of that would be 2 minus 5I. And remember, if we multiply the denominator by that, we also have to multiply the numerator by the same thing. So now we'll distribute the 3I. So I get 6I, and then 3I times negative 15I is negative 15I squared. All right, in the denominator, we have 2 times 2, which is 4. We have 2 times negative 5I, which is negative 10I. We have 5I times 2, which is positive 10I. And we have 5I times negative 5I, which would be negative 25I squared. Okay, we have a lot of work to do. Remember, all of those I squareds we can replace with negative 1s. And if you look in the denominator, we have a negative 10I and a positive 10I, which we know we can cancel. So now we have 6I minus 15 times negative 1. And in the denominator, we have 4 minus 25 times negative 1. Okay, so in the numerator, And I'm going to write this with my whole number first. I have a positive 15 and I have a positive 6i. And in my denominator, I have a 4 plus, because I have a negative times a negative, 25. So now I can complete my answer. I have 15 plus 6i. I can't combine those. They're not like terms. And in the denominator, I can write 29. And that's it. The exam 2 review sheet is complete.